All right, this video is to introduce sigma notation, learning target 10, and then ultimately be able to write a series in sigma notation at the end. I realize the video is going to be very fast, so you're probably going to need to pause, maybe rewind a couple of times, but it's only meant for those to get a review of sigma notation. If you're looking for this to teach you that for the first time, probably need to come on into tutoring and work with me one-on-one a little bit more, but here goes. For sigma notation, the sigma represents sum, and the Greek letter sigma is used. Let's see, let me get my thoughts together here. Okay, the Greek letter sigma is used here in this example to represent the sum of the first, the number at the bottom represents the number you start with. The number at the top 5 represents the number you stop with. So we're going to find the sum of n equals 1, 2, 3, 4, 5 of the series/sequence 2n plus 5. So we'll take 2 times 1 plus 5, 2 times 2 plus 5, 2 times 3 plus 5, etc. and get 7 plus 9 plus 11, blah, 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 all the way to the 5th term, which is 15. And then you'll add those up and get 55. Because that pattern is arithmetic, we could have also used the sum of the arithmetic of those 5 terms using the formula 5 divided by 2, first term 7 plus last term 15, and got 55 that way as well. But the sigma symbol will tell you what term to start with, the one on the bottom, what term to end with, the one on the top, and what formula to use. We're going to look at number 1 here together, and then probably talk about number 2, and then I'll just show you the answer to 3 and 4, and we can talk about those answers. Number 1, it's literally saying sigma to find the sum of the first through the 6th term. So n equals 1, 2, 3, 4, 5, 6. Plug them into the formula that they provided, the explicit rule: 1 squared plus 1, 2 squared plus 1, 3 squared plus 1, 4 squared plus 1, 5 squared plus 1, 6 squared plus 1, and you get 2 plus 5, 2, then 5, then 10, then 17, then 26, then 37. And now that you've got that list of numbers, 2, 5, 10, 17, 26, 37, you add them up. And I'm going to cheat a little bit, pull up the finished notes that we're going to be referencing in just a moment. You can kind of get a sneak peek on that as soon as it loads. Here are the finished notes. And you can see that adds up to be 97. So 97 is our sum. Since that's neither arithmetic nor geometric, that's pretty much the only way to add those terms in that series. Number 2 is an arithmetic, and it says start with n equals 2, start with n equals 2, and stop with n equals 6. So find the 2nd, 3rd, 4th, 5th, and 6th term, and then add them up. So 5 times 2 plus 1, 5 times 3 plus 1, 5 times 4 plus 1, 5 times 5 plus 1, and 5 times 6 plus 1 is going to give you 11, 16, 21, 26, 31. And again, I know I'm going really fast because this is just an overview. Feel free to pause the video and look at it closer, but we're just plugging those in. But we're just plugging those n values into the formula 5n plus 1. You add those up and you get 105. Now because it's arithmetic, we could have used the arithmetic formula: sum equals blank over 2 blank plus blank. First term being 11, last term being 31, and we're adding up 1, 2, 3, 4, 5 terms. So sum of those 5 terms is 5 divided by 2 times 11 plus 31, which will also give you 105. All right, real quick, number 3 and number 4. Number 3 is asking you to plug in to add the first through the fifth term of this pattern. So I'll show you that answer. You plug in the first, second, third, fourth, fifth here. Add them up, 3 plus 9 plus 27 plus 81 plus 23, you get 363. And because it's geometric, you also could have used the geometric formula, taking the first term 3 minus the first term 3 times the r3 raised to the exponent 5 divided by 1 minus r. And you also could have got that answer 363. Actually going to work number 4 because I remember that it brings up another issue. One that if you are adding the first through the 50th term, you're not going to want to probably write all 50 of them, so you're going to want to find a shortcut. So you may not realize it's arithmetic at first, just looking at the formula. So let's plug in a few n values, 3 times 1 minus 5, 3 times 2 minus 5, 3 times 3 minus 5, and 3 times 4 minus 5, to explore what kind of pattern this is. -2, 1, 9 minus 5 gives us 4, 12 minus 5 gives us 7, and we can start to see that this pattern is adding 3. Therefore, it's arithmetic. So I start to use the arithmetic formula, and immediately I realize there's an issue. I don't know what number n is. I don't know how many. No, I do. I'm sorry. I know that's 50. I'm sorry. That is 50 because we're adding the first through the 50th term up, so those are 50s. The first term is -2. But the thing that we don't know, so sorry, I had to pause the video. The first term was -2, but now we need the a sub 50th term to go here, and we don't have that. It's not given, but we can find it by plugging in n equals 50 into the formula, into the explicit rule, and get 3 times 50, 150 minus 5, 145, and then we can put that 145 into the formula and finish the formula. That'll be 25 times 143, which will give us, we already got the answers over here, it'll give us 3,575. So that's Learning Target 10, Part 1. I'm going to stop the video there because that's just using the sigma. Part 2 video will be showing how to work backwards, how to take a list of numbers, a series, and write it in sigma notation.